Alrighty, so here we're going to be looking at an Ohm's Law analogy. Here we have our voltage. Now, the voltage is the energy behind the circuit, and it is pushing the amps through the wire. So the higher the voltage, the more that little fella is pushing, and the harder he is making the amps work through. In the blue here, we have the amps. Now, amps represent the flow of electrons. Now, the amps are pushed by the volts and they are slowed down by the ohms, the resistance of the circuit. So the voltage is the fellow in red. He's pushing the amps, which is the rate of electrons, through the circuit. So if you have, say, 10 amps, think of that as 10 electrons flowing through the circuit per second. And lastly, in the green, we have the ohm boys, or the resistance. And the higher the resistance, the tighter that rope is being pulled. Now, if the rope is being pulled tight, it means that the volts have to work harder to get the same number of amps through the circuit, and vice versa. If you have a constant voltage and you increase the resistance, the number of amps or electrons traveling through the circuit will decrease. This is a little analogy that will work for Ohm's law, and it's a good way to visualize what's actually going on inside the circuit. There are little falters, and it doesn't work for the entire of physics, but for this term, this will be a good little analogy and a good way to think about it. You can also think about this in terms of water, where voltage is the pressure being applied to the water, amps is the amount of water flowing through a pipe, and ohms is the thickness of the pipe. So the resistance is how thick the pipe is. Now, obviously, if you have a lot of pressure behind a thin pipe, you will still get a lot of water flowing through it. However, if the pipe was thicker and the same amount of pressure was being applied, more water would flow through it. So either the water analogy or this little humorous analogy with the fellas pushing each other through the hole will suit for this subject. Alrighty, so now that we have an understanding of how electric circuits work, as far as Ohm's law, we're going to look at an example of a calculation, just a very simple one. Here we can see a very simple circuit. It's got a battery in the red here with a voltage of 18 volts, and we have a known quantity of resistance in the lamp. Now, we don't really care about the lamp except for the 3 ohms. Doesn't matter if it was a lamp or a resistor or an oven, it would not matter. And what we need to find here is the unknown quantity, which is our current, okay? And I'm going to be working these calculations on the side. So the first thing I would do is write out what Ohm's law is. It's going to be in the blue. Okay, Ohm's law is V equals IR. Now our voltage here is 18, so I would sub in 18 volts. I'm going to drop the units for now. Equals our unknown variable, which is I. Now I is the same all through the circuit because it's a series circuit, times our resistance, which is 3. And now we have a simple equation which we need to manipulate and rearrange to get I by itself. So I've got 3 times I on one side, and I have 18 on the other side. To get the I by itself, I divide both sides by 3. Cancel those out, and I'm left with I equals 18 over 3, or 6, and the standard unit for I is amps. And that is a simple calculation of how we solve Ohm's law.